So students, question number 9 is asking what are electron deficient compounds? And are BCl3 and SiCl4 electron deficient species? Explain. So student, first of all, let us talk about electron deficient compounds. These are those compounds in which central atom either does not have 8 electrons in its valence shell, or those which have 8 electron in the valence shell but can expand their covalency. Beyond 4. Due to the presence of d orbitals. Right? Those species are called as electron deficient molecules, right? In which the central atom does not have the 8 electrons, right? In its valence shell. Secondly, if they are having 8 electrons in the valence shell, but they can expand their covalency beyond 4 due to the presence of empty d orbitals, right? So now let us talk about BCl3 and SiCl4. Are these electron deficient species? So students, we know that in BCl3 boron has 6 electrons in its valence shell, right? Therefore, it is electron deficient compound. As such, it can accept a pair of electron from ammonia to form a duct. So we can see that BCl3 reacts with ammonia and it forms a duct, right? And here BCl3 acts as a Lewis acid because it acts as a electron deficient species because of 6 valence electrons in the valence shell, and it wants to complete its octet. Now let us talk about SiCl4. So student, SiCl4, in SiCl4 silicon is central atom which is having 8 electron in its valence shell, right? But it can expand its covalency beyond 4 due to the presence of vacant d orbitals. Due to presence of vacant d orbitals, right? SiCl4 therefore should behave as electron deficient species, right? But if we say that it can accept 2 chlorine atoms, right? 2 Cl negative ions, not atoms, ions, to form SiCl 6 2 negative, right? Then it is not possible. Now, why SiCl 6 2 negative is not possible? If we are saying SiCl4 is electron deficient species and it can accept 2 and it can accept electrons due to the presence of vacant d orbitals. It means that SiCl6 2 negative should exist, but it does not exist. So student, reason is 6 large size chlorine atoms cannot be accommodated around small silicon atom, right? But in the other case, if we add two fluorine ions in SiF4, right, then it will exist. Means that SiF6 2 negative is possible, but SiCl6 2 negative is not possible because of large sized chlorine atom, right? Because six large chlorine atoms cannot be accommodated around small silicon atom. Second reason is due to the big size of chlorine, interaction between the lone pair of chlorine and the empty d orbitals of silicon is weak. Between lone pair of chlorine atom and empty d orbitals of silicon atom. Right? So due to these two reasons, SiCl6 2 negative is not possible. Right? So students, if you want to know the solutions or more questions, you can download Y School, the learning app.